This is another example of product of inertia by integration. It's a relatively simple example. I had it in my notes, so I just included it here. Again, it illustrates the same principles we did with our first example. And again, I used three different DAs, a vertical DA, a horizontal DA, and a double integral approach. And again, a product of inertia by integration is more forgiving. It allows you to use any DA as long as you define your X tilde and Y tilde properly. So this is a basic example of an area that's defined by Y cubed is equal to X, simple function. X varies from 0 to 1, Y varies from 0 to 1, and our dimensions are in inches. If you write the parallel axis theorem in differential form, you have a dixy is equal to di bar xy plus x tilde y tilde dA. Because no matter what dA you choose, whether it's a dx dy, or whether it's horizontal, whether it's vertical, all of those are rectangles or squares. And so all of their I bars are 0. And so you're left with the integral of xy is just x tilde y tilde dA. If you choose a double integral, if you take dA to be dx dy, in this case, I took x from y cubed to 1, and then I took y from 0 to 1. You could have done it differently, but I did it that way. And evaluate the double integral and put it into your calculator. You integrate that, you get 3/16 inches to the fourth, or 0.1875. If you choose a vertical element, then our dA is y times dx, but my y is equal to x to the 1/3. And so I can plug in x to the 1/3 times dx is my dA. My x tilde is x. My y tilde is 1/2 of y, which is 1/2 of x to the third. So I plug in my x tilde, I plug in my y tilde, I plug in my dA, and then I can set up that integral and integrate it. And again, I get the same answer, 3/16 inches to the fourth, or 0.1875 inches to the fourth. Finally, if I choose a horizontal element, again, I'll use the parallel axis theorem in differential form. The integral I get is x tilde y tilde dA. If I use a horizontal element, then the dA is my x right minus my x left times dy. My x right is 1. My x left is y to the cubed. My y tilde is y. My x tilde is the average of x left plus x right. And so it's y cubed plus 1 divided by 2. And so my integral is a y tilde, which is y, my x tilde times my dA. And you can expand this guy out and multiply through to set up the integral, basically like this. Or you could just plug it into your calculator, either way. And then my next example, I think or one of my next examples, I use the calculator for it and show you how to do that. So relatively straightforward.